Welcome, everyone. After 2 years of pandemic, we decided to resume PyMunich. PyMunich has a long history. And even before PyMunich, there was a Python user group Munich for like, how long? 10 years? 15 years? 20 years? So there is quite some story. We have here all of our organizers, almost. We have Alexander Loel over there, who started it 20 years ago. Then we have Diba over there, who is organizing Meetup with me since 5 years, I guess. Then you have me, your clown, and we have our nice hosts, Alaska. So today we have 3 talks. I'm doing just a quick overview of what's going to happen now. We have 3 talks. Between the talks, we will make breaks so you can grab a beer, have a snack, feel free to network and so on. We will warn you when we start again. Then we have a live stream. We had it before, but it's the first time when we promise that since now all events will be streamed both live and happening actually offline somewhere. So we're not sure it's even working. I mean, maybe I'm talking now to a turned off microphone, but I hope it works. So please, whoever is watching this online right now, let us know. Yeah, we are streaming on the PyMunich YouTube channel. Because of our conferences, it has quite some people, so I'm sure somebody is watching this right now. Hopefully we'll get okay. Hopefully we'll get some feedback. Good. So we have 3 speakers. To save some time, I won't give any more introduction. I guess we want to introduce Alaska now. Juliana or Katarina? Katarina. All right. Please, a warm welcome to everyone. And Katarina.
Yeah, welcome everyone from our side, of course, too. Just to give you a quick overview what we're doing at Alasco, because I've been asked this question now already a few times. So Alasco tries to digitalize and also do the real estate industry greener. And we're doing this by 3 main functions. So one is a cost and controlling management function. So you can do your invoice workflows, for example, over Alasco and just make it way smoother and also faster and more efficient than before with like paper invoices or Excel sheets. And the other 2 functions are more for asset managers in the real estate industry. One is an ESG function, that means environmental social government. And what we try to do is to tell our clients how they can reduce their CO2 emissions and save energy. So what we tell them is if you put solar panels, for example, on the roof, then you can save that much energy and therefore also that much money, because the real estate industry is responsible for over 40% of the whole CO2 emissions. So yeah, that is a big goal to reduce it. And also what is possible to manage your revenue over the over Alasco, over our software, yeah, to keep track what you earn and what you invest as well. So yeah, just a little overview of what we're doing, and I think Ilyana wants to tell a few words about the
Yeah. Yeah. So hi everyone. Some of you know me. I've been involved in Python a little bit, just a tiny help from my side. So now we are hosting at Alasco the first hybrid version of the Python event. So whatever comes into the page and you have some feedback to us, please come and talk to me or Kata. I'm Uliana, just in case, and this is Katarina Kata, if they allow to talk. Kata is fine. Yeah, it's good. You also could see others Alaskans. We are wearing this T-shirt as well with our values, or like the one here. Like you could grab those people. And if you have some other questions about the stack we're using, it's mainly Python, Django, React on the front-end side, Fast API. And one of our speakers will talk more about it. So other than that, enjoy, have fun. We will have some breaks. Let's chat and just exchange the thoughts on everything about Python. Thank you.
My name is Francis. Before I get started, just a big shout out to Anton, Liana, Alaska, of course, and everyone who's been responsible for organizing this. So just quick round of applause. Yeah, so my name is Francis. I'm a backend engineer here at Alasco. I've been here for about 2 years, working primarily with Django and more recently with Pydantic. My interests are, I never really thought about what my interests would be, but my interests are mainly movies, Netflix, good music, and spending time with good people. So pretty general ones. Anyway, some of you may be looking at this and thinking that it's a bit of a weird way to phrase a talk, given that Django with something else isn't exactly that common. I just want a quick show of hands, though. Who here has ever touched Django? Ever? Okay, so who here has touched Django on touches it on a weekly basis? And apart from like anyone at Alaska, and anyone who uses it on a daily basis. All right, we have one. And one last one, like who prefers tabs over spaces, just so I know like I'm in a comfortable environment. All right, okay, cool. So it looks like everyone's with spaces. Yeah, so as I said before, this conversation may be a bit controversial to some Django developers. One thing I need to kind of go over first is how we incorporate Django here at Alaska. We have our API layer. Then below that, we have our serializer. So both coming from Django, and then our services, and then database. And we tend to make use, or we primarily make use of the vanilla kind of packages or the classes that come out of Django, such as like the API view set or the standard serializer. So we don't make use of model serializers. And as a result, we also have we base our architecture off service layer architecture. Now, the second controversial part is that what we've started to employ at Alaska is Pydantic, and because we use services and with that we use DTOs, we've come to the realization that Django serializers may not be needed for our use case at least. And of course, this is not like a general rule of thumb for anyone else that use Django, more of a food for thought. So the aim of this is pretty much how we have started to use Pydantic within our Django ecosystem. So why is it that we want to use Pydantic? Well, first of all, it creates a more Pythonic experience as Python has started to mature using this, or not started to mature, but has now allowed for this typing library to kind of become more popular. We want more of that. It helps our IDEs, it helps developer experience. And for developers, we want that. It's helped me a ton of times when it comes to understanding functions I've never seen before, knowing what has to come in, what has to come out. It also avoids needless abstraction. So in our case, the serializer starts to become redundant, and you'll see that as we progress in this presentation. And finally, what every developer loves is we want to maintain and have a repeatable pattern when it comes to both development and for testing. All right, so I've come up with a quick example of what an API would look like for us when it comes to using the Django ecosystem. So forgetting about Pydantic for a second, we have here just a very basic one that lists a bunch of people, and you can also create a person. So a person may include a first name, a last name, age, birthday, what have you. So not to go too deep into how all this works, but the get method here is pretty much calling a service function, retrieves a bunch of people, maps them to our person DTO, which we'll see in a second. And then we serialize that and then return that as a response. And then we have our post, where we have a bit more going on, where we first map the data that comes with the post request to our serializer. We then just make sure everything is working smoothly. So character fields are character fields, and you're not sending a first name as an integer or anything like that. And then we call a service function, which just creates a person, and so on and so forth. And then finally, you have a response, which is the person that you called. Now, one thing here is there's a lot of juggling around happening when it comes to our serializers and our services and our DTOs. There's also this validated data that we're using a lot in .data, which, yeah, depending on how you think of it, it may be a bit more than what's needed when it comes to just having something so simple. So what does our serializer look like? We have just the basic stuff. We have the ID. And again, we're not using the model serializer or anything like that. We're just using the straight vanilla serializer. ID, first name, last name, age, birthday, and with some constraints and lengths added into it. The problem, however, is that if we were to read the data that comes from this serializer, so if we were to access anything that has been serialized, we would have to access it as a dictionary. Now, dictionaries are great. Everyone loves dictionaries when it comes to Python. They're powerful, they're fast. But when it comes to accessing things via strings, we're prone to typos. And from what I know, at least, when it comes to using strings in dictionaries, your text editor won't really pick up on whether or not a key will exist. If it does, then please let me know. Like, that'd be great. But this assumption is going off that we have just 5 properties in our serializer. If you have many, then again, you're opening yourself up to more risk. So this is just 5, but imagine if you had 10 properties in your serializer, it becomes a bit more of a headache when it comes to trying to track down a bug. So how did we go about solving this? Now, there are probably many ways out there, but given that we have a service layer architecture, we decided to make use of our DTOs. Now, we override this to internal value. Now, there's also to representation, and the to representation is probably more useful for reading data, but our to internal value, just for the sake of simplicity, we've just kept this in here. But what we do is whatever data is sent to the serializer, we pretty much just map that to our DTO. And then as a result, we don't have to access the properties using a string. We can do something like person.first name, person.last name. And our DTO looks like this. So we just have first name, last name, age, etc. And I feel like I'm repeating myself a lot here. And the reason why I am repeating myself is this is somewhat similar to how we defined our serializer. So our serializer, we had first name, but instead of mapping it to a string, we just said it's a char field. Same for last name. Our age, we set to integer field, but in this case, we're using the straight Python int and allowing it by default to be none. And if you were to kind of convert that into JSON, it'd just be null. Birthday is a date, and ID an integer as well. So a lot of repetition already when it comes to our serializer and our DTO. And here is just a helper class method, which allows us to take an instance from our model. Not really that important to this conversation, but just for show, just we allow our model to be mapped to our DTO, and then we can just do whatever we want with it. Okay. So thoughts so far, as stated before, this is quite repetitive. So the abstraction between serializers and DTOs. And as stated earlier, we want to avoid needless abstraction that just becomes confusing, and yeah, it just piles on more unnecessary code when it comes to development. Fast API in the future. Now, this is something that at least the team I work in, we're pretty excited, or hopefully one day, I'm looking at my engineering manager here, but to hopefully one day use Fast API rather than Django, just for the novelty of it and also the cool stuff that comes with it. And having something that that Fast API makes use of would be nice. And having serializers there and all that, it doesn't help exactly when it comes to Fast API. We need to look a bit beyond that. And we know that DTOs work well when it comes to a service layer architecture, just to kind of pass data to and from our web application layer to our service layer, and then to work well with our database or whatever ORM you're applying to when it comes to Python. All right, so these are our thoughts, but where do we go after this? So enter Pydantic. Now, Pydantic is a pretty, I don't really know how to describe it apart from that it's pretty cool. It's kind of like it adds a bit more than what data classes have to offer when it comes to the Python standard library. And yeah, what does it offer us? Well, first of all, it gives us data validation and type checking. Now, I want to avoid making this like an extensive tutorial on what Pydantic does, but rather how we found it to be useful for our team. So yeah, it allows for data validation, type checking, comes out of the box. It's very easy to turn into JSON, but when it comes to a data class or the standard library data class, there's a lot more workarounds that happen with that. And finally, friendly errors. We all love friendly errors, especially if you're bug hunting. You don't want to read something that is heavily convoluted and be like, WTF, like, where do I go from here? So recall our DTO friend from like a few slides prior. Again, nothing has changed. Now, here is what it would look like if we were to use Pydantic. Now, I want all of you to kind of have a close look at this because I'm going to ask a question in a second. And this is our Pydantic version. Now, who here can tell us what the difference is between our data class that we showed, our DTO that we showed earlier, and the Pydantic DTO? The date? And where's the X buzz? Like, damn, it's over there. Okay, never mind. No, it's not the date. No. So who said base model? Yeah, exactly. So in this case, maybe this is a bit unfair, but yeah, before we have this data class decorator that we had on our old person DTO, and then finally we instead inherit using base model. So that's a very small difference, and of course this is a very basic example. There will be times where you probably have to do a bit more, but for this case, and for a lot of our cases at least, it's pretty much been a change of going from using the data class decorator to using the base or inheriting from base model. All right, so just some freebies of what comes with our person DTO or using Pydantic is that it's if you remember our serializer, we added some constraints to it. So for example, our first name has or back when you looked at the char field, it had a max length of 255 characters. We can do the exact same here. This constr or constrained string comes with Pydantic as well, and you can pretty much do the exact same thing by saying that first name has to be a max length of 255 characters or less. And if, for example, we wanted to add a bit more kind of like further logic, we could say, for example, we only require a person to be above the age of 18. So if our age is less than that, we can write invalidation directly into our DTO. Now all you have to do is just use a validator decorator and just reference whatever property that you're trying to validate. Okay, so going back to square one, looking at our API, this is what you were faced with earlier, where especially when it comes to our post requests, there's a lot of juggling around with serializers and DTOs. But what would it look like if we were to now use our person DTO? Now this is where everyone goes, okay. So we pretty much X out most of this, and as a result, we clean it up, and we love clean code. And as a result, we pretty much just have to, when it comes to our get, our service just returns a person DTO anyway, so no problems there. The serialize method, which I should show you actually, is coming from, I just added like a helper method into it, which just serializes this DTO. Very easy. You can't really do something like that so well when it comes to Python data classes. And all we have to do is just kind of the Pydantic or every Pydantic object comes with this JSON call, and this JSON load just make sure that nothing's stringified if you're creating like a list of objects. And yeah, so this, back to our API. All we're doing when it comes to the post request is we're just mapping the request data to our DTO. So ID matches up with ID, first name, etc. And then we throw that DTO back into our create, which we had in our old serializer as well. And then finally, we just respond the same way as we did before. Now, one thing to also mention when it comes to this, like the serialization, if you do already use Fast API in your code base, there is like a JSON encoder that comes with it, and you can use that as well free of charge. And I think it just covers a bit more ground rather than what I implemented for the serialize. But that pretty much concludes the talk time-wise. I don't know if I'm below time or... but yeah, if anyone has any questions, please feel free to ask. Yep. Okay, yeah. Do we use model serializers now? This is a perfect question I'm looking at, because this is something that I was hoping someone would ask. In our, yeah, so just to kind of clarify again, so our serializers use the vanilla ones, and the model serializer we found to be, hold on, actually, I've got a note for this one. Yeah, so when it comes to the model serializers, I don't know where I put it. Yeah, when it comes to the model serializers, we have, so we use service layer architecture. And what we found was that when it comes to our specific use case, having this sort of architecture helps like draw borders between different teams. So everyone knows where they're coding. And also, I think at the time as well, like it was more of serializers are a bit easier. The plain vanilla serializers are a bit easier to understand than in regards to model serializers. There's also the case or the general case where we want things to be consistent across all serializers. So for example, with the model serializer, it's a direct mapping to the model, or usually is. Whereas in our case, a lot of our properties in our post requests aren't in direct relation to the model itself. So there's a bit of like processing going on there. And yeah, the kind of advantage of having our services as well, that we just found it easier to test with services. We primarily use like functions rather than like class repositories or anything. And I mean, this is again, very depends on which team you're talking to. But for us, we just in general found it easier using serializers or the vanilla serializers over the model serializers. I hope that answers your question. Yeah, the hope is that one day we may actually go to Fast API. I mean, of course, that's depending on who you ask. Some people prefer Django, some people prefer Fast API. But of more recent times, we started to apply Fast API into our code base. Some teams are using Fast API. Others are looking at it as if like we're the kids stuck inside and watching everyone else play outside. But yeah, the one of the perks of having Pydantic in now is that if we were to move over to Fast API, it helps that migration because we've already covered some ground.
All right. If there are no more questions, are there any? Then I have one. Francis, you have a YouTube channel, don't you?
Yes, I do have a YouTube channel.
He's a nice and shy guy. Open it.
Oh, okay.
And we do research our speakers, of course. We check if the guy knows what he's talking. This guy knows a lot. So
I have like,
check it out.
It's an undercover project, but I can. If I go to my YouTube homepage, I think everyone will judge because of the stuff I watch.
It's educational stuff. It's useful for this group.
Oh, that's the wrong one. That's not me. So yeah, this is my channel.
So remember the name, Rhythmic. Cool stuff about tech. That's my opinion. I didn't know Francis before actually today, so absolutely objective opinion. Please check it out. It's cool. And yeah, big thank you then. 5-minute break. What do you think? Let's give Eugene a second chance. So grab your next beer, but this will be a short break because yeah, running a bit out of time. So grab something and we continue. Good job.
Thank you.
Good job. All right.
All right.
Finally, the long-awaited talk of Eugene.
Yeah.
Please welcome number 2.
So how is it going? Have you ever seen a movie Gone in 60 Seconds? Yeah, nice movie. If you don't haven't seen, I recommend it to you. Nice movie with beautiful cars and good actors. and pretty interesting. I'm Eugene Burdin. I came from Ukraine about 1 year ago. I just came to Munich to check how live is here, how is Munich, how is soul of this city, and now I can say I love this city. I love this place. Beautiful and near to Alps. So I'm a software engineer. I'm working on 2 projects. First is Document AI platform. It's the big platform that recognizes data from the documents. And another project is analytics platform for restaurants. I love traveling. I love adventure. I love visit natural places. I love them. Sometimes it's difficult to get somewhere far away by public transport. So a few months ago, I decided I need a car. I thought, what the car it will be? If I'm in Germany, it should be a real German car. It should be truly German car. After some research, reading some reviews, I decided it should be Golf, Volkswagen Golf. Yeah. Okay. Next, I try to find it. I make it maybe 10 test drives, 10 reviews of real cars, and find one, and fall in love with it. It's a pretty old car, 1999 year of production. Sometimes I spend time to fix it, but mostly it takes me to beautiful places in mountains, lakes. Even once I slept inside the car near the lake. It was brilliant. So I respected this old, but I respect it. As a responsible driver, I'm usually trying to keep my tank is full because fuel should be on the top, and it costs money. And I thought, how I can save on it? I just understand that on the gas station prices can be changed during the day. For example, one price in the morning, another price at night. And I thought, okay, I should know when is the best time to buy fuel, and best time and best place. I thought, okay, I'm a programmer. I should write a script. I write a script that go to like fuel API, fetch the prices, and should analyze somehow, and send me notification. Okay, this script takes prices. If I set a threshold, if it's okay or not, just manually analyze the prices, and like €2 is okay for me or not. And if it's like lower than €2, near to me, about in 5 kilometers, it will send me notification to Telegram channel. So okay, we can just here's a schema of this system. Schedule trigger. I set it up for events three times a day: morning, evening, and midnight. It will trigger application that will go to API and check the threshold and set the notification to me. We can check the script on moment. It looks pretty simple, just one method. So users, I just set it up here. My user, client for interaction with API, and Telegram bot sender to interact with Telegram API. And checks prices. It's like pretty simple method that contain my huge business logic. Okay, I run it locally. It works well. What do next? Probably I should deploy it somewhere. I thought I can run it on demand on my laptop, on my Raspberry, or on desktop, but it's a lot of problems. It should be all time power supplied, all time will have a good availability, network availability, and I should manage this operating system environment and so on. And of course, fix my bugs. And another way, run it in the cloud. Here, if I run it in the cloud, I should only set up the cloud resources and take care of my bugs. As I a bit familiar with GCP, I have some experience with it, and it has some trial period for new customers and have a lot of services. I decided let's run it on GCP. So, okay, which way we can do on GCP? How we can run it? There is a few ways: Computer Engine, Kubernetes, Cloud Run, and Cloud Functions. You can check out in documentation what of this service like main reason in what education, in what the situation for which task you can use these services. I decided to use Cloud Functions because it's simplest as for me. So, and probably we can check it. So, GCP time. Okay. Yeah. Small notes. Have you ever used GCP? Of course, yes. So you're familiar with dashboard, with the functions. So I have already pressed it up with IAM roles. You can see gas price checker account, service account that has permission to invoke cloud functions and have permission to read and write data in data store. Also, I have pre-stopped. One moment. Where is it? Already, I have pre-set up secret manager. It's pretty simple. Just give the name to value, give the name to the secret, and put the value. Huh? Zoom in? How can do it?
Okay, don't zoom it.
Okay. Nice. Good. Control plus. Okay, it's not my laptop. I'm a bit scared that I'm.
It's not his laptop. If you open something,
Yeah.
trouble, so it's okay.
Okay, so secrets. I have set it up, and probably that's all what we need to run my function. So I have already created some. This function gas price update. It's work now. It's like production version. I'm gonna show you the demo how easy we can do it. I read an announcement that there was I can do it in 60 seconds. So we can check it. If you have stopwatch, you can make a bet with each other, and let's see can I do it or not.
I'm checking.
Okay. So let's start.
3, 2,
Okay.
1, go.
Okay, demo. Oh shit. It's not my laptop. Okay, demo 1. 6 I will use region Europe 6, and I will use okay, HTTP trigger.
It's okay.
Next, okay. Next.
Again and again until he's reaching 60.
Okay. Next, I set up the maximum numbers of instances.
20 seconds left, man.
Oh shit. I set it up a service account, and then build. I will left as default, connection as default,
Countdown from 10.
and I should.
7, 9,
Fuck.
8, 7,
Shit, I'm full.
6, 5, 4, 3, 2, 1, go!
So I can't. Probably it's not. It's because it's not my laptop.
Okay, 20 seconds extra.
Okay. So Telegram API key as environment variable. Oh shit. I made a mistake. Yeah, no way. Yeah. Telegram. Okay. Okay. The fuck's the bet. Let's do it again. Success, and we can check it in Telegram. It works. Great. Time is 2012. Cool. So okay. I set it up. The function. I set it up. Cron job. What's next? I would like my application to be a bit responsible. So I decided to implement a Telegram bot backend to handle commands and store user settings somewhere. I implemented the code, and there is a question how we can store the data. Okay. Here's the schema. What changed is only Telegram bot backend that can go to HTTP API and store data to user storage. Pretty simple. Second question, where we can store the data in Google Cloud. Most relevant services is Cloud SQL and Firestore. I decided to use Firestore because, as I understand, it's document-oriented and fits good for my data schema. So let's go to GCP and check it out over there. Here's here's a data store. I already have two users, me and Anton. Here's the data what I store here. It looks pretty same like I show you in first version script. Okay, we have source. We have data storage. We need somehow deploy our bot. This bot handle HTTP request because in my implementation, Telegram will send callback to my bot. If someone send the message or command, Telegram API will send callback to bot, and the bot will handle command and do some magic. Okay, how we can deploy it? I decided to use Cloud Run against of Cloud Functions because in the case, in my opinion, if when Cloud Run working as allocating CPU time every time allocating CPU, it will be cheaper than every time invoke the function because Cloud Functions has fee per request. It has to be big limit, but like it's my opinion, I did make a calculations, just testing. Okay, I run it in Google Cloud. I want to show you the demo how I did it. Just pretty simple, like functions. Click create service. Select the latest build image and Oh.
Tell us how much time did you spend on building the image?
How much time I spend on building image?
Yeah.
You mean in the cloud?
I mean, in general, from end to end. Like, I mean, it's a kind of sometimes it takes a lot of time basically to build your own image. How is it easy with Google to do it and deploy your image?
I spent not too much time. I spent about maybe 40 minutes. I just connect. I have connected my source repository to GCP project, and just make a. I don't know. There are pretty understandable instruction. I just select the region where I want to store storage. When I want to store the images container, and that's it. And enable all APIs, probably Artifactory, Cloud Build, and push the button build, and that's it. And of course, I spent some time to write a Docker file, but it was simple.
So let's go through the top.
Okay.
Questions, and maybe we'll put the next.
Okay. Let's finish it. CPU allocation, 10 instances. Memory, let it be by default. Connections, it should have, yeah, let it be by default. We should give it account, gas price bot account to have to give the ability to the bot backend to communicate with data storage. And yeah, what's next? I didn't assign that. Oh, shit. Let's do it again. Terraform is a great thing. Oh. I will give ability to handle unauthenticated request, because I didn't set up a token into.
We believe it. We believe it.
Yeah. Okay. 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 So I can make a change here. I should set up secrets like in previous example. Oh shit. Just set up secrets and Django. By default and security, I will select gas price bot. Yeah, looks correct. Okay, what's next? I want to show you the comparison between prices of Cloud Functions and Cloud Run. Why I decided to use Cloud Run for backend. It's as we see here is some price for first 2 million invoke is free. The next will be 0.40 And this is prices for Cloud Run, where CPU allocated only. Okay, I think so. And for always allocated CPU. So that's pretty much it. What's next? If you're interested of GCP and want to start with something, try to use documentation. GCP service is pretty well documented and really understandable and easy to understand and easy to try. Take courses, take cloud training, and certify, pass the certification. Okay. So,
Right, then,
yeah.
Thank you.
Thank you for attention.
Question time.
Yeah.
Question time.
I hope you enjoyed.
Question, please. We had some during the talk.
Yeah.
You're looking carefully at the selection of memories if you think twice as much for 256 as for 128.
Yeah, but I just used by default.
He's rich.
And just, yeah. Yeah, that's true.
He saved on the car pretty well.
Wouldn't it be awesome if these services could just have a memory allocator, so you pay for how much memory you allocate, not how much memory you decide in advance?
Yeah, I understand. It's because like it's a demo. I just left it by default, but I thought about that, how much memory my application really need, and I decided to use the minimum because there was just make a request and put the data to Telegram, and so it's minimum will be enough.
There. Please.
Okay.
I noticed the educator recommendation and the Telegram book, like getting the best place to get the fuel, right?
Not the best place. It's like cheapest place near to you. Just send the command to. I can show you how it works in the thread. Just send set the parameters via Telegram bot, and you can just press give me five station near to my location. You send the location via bot. You send your current location, and press give me a best 5 station. I would like to get E10 fuel and in radius 5 kilometers, and it will like put your top 5 cheapest station. And 3 times a day, it will send you a notification if price really good, that your threshold lower than your threshold. So like that.
Does it take into account the price change by the time you get the station?
If price change and fuel gets lower, and it's lower than threshold, it give me the notification. So in a script, like it's a simple logic. Probably will be interesting to analyze how prices changes. And yeah, okay.
I find it hard to believe that the cloud functions are cheaper. Like you get millions of calls for free. It's very short.
Yes, but as I told, the Telegram backend, this implementation works like it's handle callbacks. So if some user text some message, some like set fuel command, it's a command with mistake, it will handle one request. Every command via this bot will handle requests. My backend will handle this request. So I think but it's like only my opinion. I can tell you exactly because I haven't calculated. So okay. It's how much requests we expect. Of course, if I'm only one user, of course it's never mind.
We need to make a big applause because we still have one more speaker come here.
Okay.
For your information, it's the first Meetup talk ever of Eugene.
Yeah.
Give me a warm welcome. Eugene, come here.
I just wanted to say it is my pleasure to introduce Krishna Kalyan, and he will be speaking about this really, really cool machine learning tool that a lot of developers are using. It's called PyTorch Lightning. Builds on top of PyTorch and makes a lot of machine learning workflows easier. And in this case, you will be hearing from the horse's mouth because Krishna actually works at PyTorch Lightning. So it's my pleasure to give the mic to him and give the floor to him.
Thank you, guys. Nice to be here. So since this is the last talk, I'll try to keep it short and happy to take any questions in the middle. So we have a lot of products, and most of them are open source. And the agenda for today is that I'll introduce our open source product. It's called PyTorch Lightning. How many of us have used PyTorch before? Okay. How many of us have used PyTorch Lightning before? Awesome. So as you would already know, like PyTorch Lightning is this abstraction over PyTorch. A lot of things that you would essentially do in PyTorch would be like 100 lines of code, and if you would do it in Lightning, it would be like maybe 50 lines. It's like Keras, but for PyTorch. And we have a lot of abstractions that make it very easy for you to write deep learning code. So that's about PyTorch Lightning. It's pretty famous. And we also have a app, an idea we are building. We are not sure if it will work, but I just wanted to get a feedback because we are a startup. We are like less than 50 people, and it would be great to have a feedback. So I thought I will just come. So I'm from Stuttgart, so I thought I'll just present here. So I'll want your feedback on the Lightning app. It's basically a framework that we're developing. Like we saw in the GCP talk, right? It's like you have to click so much and figure out like where to click. You need to know Terraform. Perhaps we can do it a little bit more easier in a Pythonic way. Perhaps that's a way. And then how do you build this application and deploy it to the cloud, right? It should be Pythonic in nature. You can deploy any Python application without too much code. And I'll probably present a demo if we have time. And then obviously I'll take some question answers. So PyTorch Lightning is a very famous open source framework. It's mainly comes from Meta. So the founder of our company used to work in Meta as a research engineer, and he found that a lot of the stuff that they were doing in PyTorch would be repeated again and again. And he decided to create some abstractions. And now it's become like a huge thing. There are more than 24 million downloads, more than 700 contributors. So I also contribute back to open source. And there are more than 9,000 projects using PyTorch Lightning itself. And we've got a great Slack community. So if you want to join, feel free to join, ask questions. So essentially, when you write a PyTorch code, it's just everywhere, right? You just write line after line after line. So what we did is that if you had to write a PyTorch Lightning code, is that you need to decouple the stuff that you'll write again and again. So the first stuff is that like you have your own research. Like for example, you need to do some experiments or you need to do some research on specific thing. You perhaps want to remove that from your code and you just want to focus on that. So you have to decouple that. And then in your research experiment or even in production, you'll first try it on different data sets. First, you will try it on maybe a sample data set and see if your model is behaving well, and then probably scale. Or maybe you will try on different sets of data, like maybe on, let's say, the data set of Munich, then you'll expand to data set of Germany, then data set of India, because it's different, right? So you want to decouple your data. But the code to write the data set itself is the same always. So you just want to decouple that. It's pretty common. So we abstract that. And then finally, you have some boilerplate code. For example, in PyTorch and TensorFlow, it's pretty easy for you to make mistakes. Like for example, in evaluation, if you forget to turn off that you don't need gradients, you might make that mistake. Or you may forget to put your model in inference mode. So all this boilerplate stuff that everyone has to do in PyTorch, we take care of that in PyTorch Lightning. So this is the first part, the open source part, right? And we have three main aspects in your code when you create a PyTorch Lightning code. So you have the trainer. So in the trainer, we give you a lot of powerful abstractions. Like let's say I have written my PyTorch Lightning code. So I could just say in my trainer script, run it on one GPU. I could say run on 10 GPUs. I could say run on 10 GPUs multi-node, right? So all this is just a simple flag that you will change. Or you could say run it with fixed precision, a 32-bit or 16-bit precision. So you could, your code itself becomes like a flag that you keep on changing, and you can be very powerful with that. But if you had to implement that in PyTorch, you would have to download a lot of libraries from NVIDIA. We take care of all that for you. And then you have the Lightning module. That's where you write your models. And then finally, the data model, the data itself that changes over time, or the new data sets, you have a abstraction for that. So you have the trainer abstraction, you have the Lightning module where your model is, and finally the data module, like where your data is coming from. And essentially, this is how your data would look like. Let's say you're working on PET's data set. It's a very famous data set by Stanford. So you basically define, hey, it's my PET's data module, but this can be also your, what do you call, autonomous driving module, or what do you call, insurance module. So that's the thing that will change, right? And then the model, you define what your model is going to be. That's maybe perhaps only few parameters in that will change. And finally, the trainer, like here you can say how many epochs you want, how many devices you want, the precision, if you want the progress bar, and a lot of callbacks. So this makes your machine learning training pipeline really simple and robust, right? And this is just like an example of how it would look if you write it correctly. And what we need to understand is, like, PyTorch itself is a very small part of your application, right? At the end, you have to think about ML ops. You need to figure out where to deploy in my CPU or GPU, maybe in the cloud, maybe on AWS somewhere. And all that kind of becomes quite complicated when you have to start deploying stuff in the cloud, right? So we have come up with a new product. It's called the Lightning applications. So basically, you can potentially wrap any Python code within a Lightning app. And you could do potentially anything with it. So let me give you an example. You could do a multi-node training. So you could launch multiple GPUs and do multi-node training. You could do active learning. You could do reinforcement learning. You could do load balancing. So all that happens perhaps in your app itself. You could write, if you can write the code for that, the Lightning app will do it for you. We don't care about what framework you use. We just give you the primitives to build your ML application end to end. So how does this look like? So if you wanted to do this today, you need to create your Anaconda environment or a virtual environment that you're comfortable with. And the first thing you would do is you would do something like pip install Lightning. And once you do that, you get both. You get PyTorch Lightning itself, and you get the Lightning framework. And this is the only thing you need to install. But if you have an application like which has other dependencies, you would install that too. And basically, this is a very simple demo of how your application would look like, all right? So this is basically your import. This is the boilerplate, right? So just import Lightning as well. Everyone has to do that. Don't ask me why, because you'll import it otherwise, like in other places. And then you have the Python tracer script. So there are several modules that you can try. You can even do sub-process. But for this, we just want to run a very simple Python script. And maybe what do I want to do, actually? So I want to have a flow. So flow, think of it as a master. So this is where all your applications would start. And once your flow starts, what you need to do is, like, you need to tell in your flow, run this Python script. So it's called train.py. It's present in my directory, and I want to run it. And then finally, I want to say what kind of machine. I can tell it, like, hey, run it on the cloud, right? It's cloud compute, and run it on a GPU machine. And then you just say run it, right? And it will run it for you. So this is how a simple PyTorch Lightning application would look. That is running a PyTorch Lightning deep learning model. And just to show how Lightning looks like is we have this website. You can build your own apps. You can submit to the gallery, and you can share it with people. So you could build pretty much very, very complicated applications. You could do an anime perhaps converter, which perhaps converts Elon Musk to what do you call anime. So let's hope it runs. Anyway, and then this is PyTorch Lightning framework. And this is basically just for your deep learning research, which we just spoke about. And let me show you how the code looks like. So this is how your project structure would look like. you would have your application that we just saw. We just want to run a simple Python script. And if you look at the train.py, it's basically a simple MNIST example. Essentially, you could train any model. And first, you define your neural network, right? And after you define your neural network, you would basically wrap it under the Lightning module, right? That's what we said. And we will define how you want to train, how you want to validate, and what kind of optimizer you want to use. And finally, the data module. So the data module is the one that kind of is like an abstraction of your data. And here you define your training set, validation set, and then you will wrap it all around a CLI. So if you wrap it around a CLI, you can basically override anything with just a configuration parameter. So this is what the training script looks like. And now, if I want to run it, I have to conda activate, so conda env list. So I want to check which all environments I have. And as you can see, I have conda. Yeah. So once you activate, you do pip3 install -r requirements. And this will basically install the requirements that you need to run your app. And once you have done that, what you would do is Lightning app. So you want to run this app, and then you would say the name of your app is called app.py, and you want to run it on cloud. You can even run it locally. If you don't give this parameter, it runs locally. And if you just say cloud, it runs on AWS. It can be managed by you, or it can be managed by us. And then if you say name, I'll say PyMunich. And essentially, this will pack your code, so run it on a cloud on a GPU machine, and it'll run it. And while this is happening in the background, I already have a demo where I've run this so that I don't waste. OK, here we have the enemy, which we tried. And here you can see that an app has been launched. And this is the app. And basically, this is the flow where my application is launched. And if you have, and this flow is creating a run, which runs my Python script. And you can see that it just finished training an MNIST model. And it ran for around 5 epochs. And yeah, and now this app is running. So it basically had to package the code, and now it's running again. It's called PyMunich, and it'll take some time to load. And with that, we'll go to the next slide. So you can, so this is pretty powerful because you could test your app locally and make sure it works, and then you can run it on cloud. Then you can't say, hey, it worked in my machine and it's not working on cloud. We saw the demo already. Thank you. If you have any question or anything, comments, happy to learn more from you.
Anybody has a question? There was one question. Oh.
Yeah.
So if you run it on the cloud, how do you, does it also provision the resources on the cloud, or how do you configure what it uses?
Yeah, so cloud compute. So if you search for cloud compute, one second. So make sure you go to Lightning AI docs. What we found out, like developers don't want to like spend time on which machine to choose. So we give you set of abstractions, and we tell you how much CPU it has. You can potentially like configure them to what you want. So we say if you want just 2 cores, just use a CPU small. If you want a GPU, just say a GPU, and that's it.
And it spins it up, and
yeah. So it's basically just now it's spinned it up, just spin the machine up on AWS.
And then it takes it down again.
Yeah, so you have to write code to that. So you have to say the work.stop. So here you can see the cluster. I have a cluster here. It is running in my environment. And the compute you can see here, right? It is a very small cluster with 3 CPUs, for example. Yeah, exactly. So this is the website. I didn't show, but yeah, you could choose whatever machine you wanted, essentially, on cloud.
And the credentials you have configured on
Yeah, so if you are doing it for the first time, you have your credentials that are kind of like in your profile. If you billing, I guess. One second. So if you do something like this, Lightning login, it'll log in for you, and you can log in like with your Google Cloud account. So you don't have to worry about all that stuff because we make it easier for you. Yeah, please. Okay. Yeah. Yeah. Please. Yeah.
What's your business model?
We are still trying to figure that out. We thought this is something cool that we have built, and perhaps people will like it to run without worrying too much about Kubernetes and AWS and GCP. Maybe make it easier, more Python centric. So we are just speaking to customers, and the feedback so far has been good, but we are still in early access. This product is still not GA, it's still early access. If you look at our documentation, you will see some part that's not very clear, but I hope this talk was clear enough for you to understand the power of Lightning. That's a very good question. So just to give context, Grid was our version 1 of this product. And in that, we were specifically focusing only on the infrastructure, making it easy for people to build infrastructure without knowing Kubernetes or Terraform or AWS. So Grid was like, hey, run this model on Grid. But what we realized was that, okay, we have figured out the infrastructure part, but people also want to build apps on it, right? Training your ML is just one part of it. And there's no solution so far in the market where you can connect various pipelines. So you could have a label studio where you're annotating the data. And after that you train your model. So you give a command, grid train, or lightning train. So it'll train the model. And then you say lightning run. And it'll deploy an inference, like maybe an app which we just saw, right? So you could do everything end to end within Lightning. And what we also thought was Grid itself is an app within Lightning. So we have a trainer app which actually does that. We have a HPO app where you could do a hyperparameter optimization. We have an app for compressing your model. We have an app for latest machine learning research, a Dream Studio, maybe diffusion app. So we just thought that it's better to abstract everything and let the community decide what they want to build.
Thank you very much, Krishna, for this enlightening talk, no pun intended.
Thank you.
And I wanted to say to all of you that this is like, again, the first time we are doing an in-person meetup after the pandemic. So it's a special occasion for us. So thank you very much for coming. And thanks to Alasko very much for hosting us. Without you, it wouldn't have been possible. And if any one of you we want to like keep doing more meetups from now. So this is the start, and we will do more. So if any one of you wants to give a talk at a future meetup, please come up to either me or Anton. All right. Thanks very much for coming.
No, we don't need to stream it, I guess. We're done. Yeah, thank you very much to all of our speakers. You're all awesome. Thank you. Hope you will stay for networking phase and still have some Q&As, which you could reuse maybe in the future as a feedback. Thank you for coming. I mean, it's amazing seeing so many people on site, and like there is still a risk, but we are so kind of into on-site experience now that I guess after 2 years we need to figure out a little bit more and more, and then everyone else will just join and still be back to sort of normal, the new normal, I call it. If you might have someone you know as a meetup organizer, or you have some ideas for a meetup and you are willing to partner with us to be hosted at our office, just reach out to me. I will leave the slide afterwards, so it will hang here for next hour or so that you could follow us and just see, and you could just talk to me. We stay here until the end. I just have some fresh beer in the fridge. It's not so cold as it should be, but still it's there. I will just bring it back to the table, and we could still have a beer and just enjoy the chit chat together and yeah, having fun. Okay, thank you very much. Then let's
It has some rough edges, right? Perhaps at that time,
well, I
I was
mean,
running older
you
version
see
of the
us.
app.
sorry.
But
have
it
some
does
impression
show up
what type
whether
of
you're perhaps I can run it
we have
again.
here,
Yeah, exactly.
in our language.
I think I have another example, and it is
Where do you work?
Django
I know.
for deep learning. So you have that PyTorch and then you have PyTorch. And then they decide, okay, you have this deep learning model, you want to deploy somewhere. Then they create lightning apps. So